Welcome everyone to this year's course on mobile sensing and robotics. My name is Cyrill Stachniss and I'm a professor here at the Photogrammetry and Robotics Lab at the University of Bonn. It's my pleasure to welcome you and give you a very short overview of what we're going to do in this course and some of the formal requirements. So this is a course, first of all, which is taught jointly between the English Master Program Geodetic Engineering and the German Master Program Geodesy and Geoinformation. So your roll number either start with MSR or with M, depending on which study program you're in, but it's content-wise the same course over here. And we are looking into mobile systems that move through the environment, perceive the environment, model the environment, but also take actions in order to reach a certain goal. For example, in order to navigate through a certain goal location or in order to cover an environment with its sensors. So we're looking into basic techniques that mobile robots and other autonomous devices use in order to perceive, understand, and act in their world. And that's what the main topic of this course is about. We are looking here really into the foundations, how to do basic state estimation, recursive filtering, localization, basic control problems, planning. All these topics are part of that course. So when I talk about autonomous mobile systems or robots, then we can mean devices like those over here. This can be autonomous, small-scale vehicles equipped with sensors that move through the environment. This can be UAVs flying around observing objects observing the Earth. This could in theory also be satellites which perceive data and that data that we need to interpret, something that often, at least in the space systems, doesn't run online for the observations of the Earth, but the analysis of the data is typically done offline, but that's not really a difference in terms of the state estimation algorithm that you could use for interpreting certain types of data. We can look into systems, planetary rovers, for example. There, everything happens on board. Those systems need to perceive what happens around them, especially what the world looks like and how to navigate in this world. And also autonomous cars are systems, can be seen as robots that move through the environment, mobile sensing platforms that need to achieve a certain goal, for example, reaching a certain target location. And if you look into the fundamental problems or fundamental questions that we can raise in mobile robotics, then these are those two questions here. First, what is the state of the world? And the second one, which action should I execute in order to reach a certain goal state, a desired goal state, a place where I want to be? Okay, so the first question takes sensor data into account and turns the sensor data into some form of useful information. So there are typically some state variables that the system is interested in knowing. This could be its own location, this could be the location of 3D points in the environment, or any other type of information that the system can gather through its sensor data. And this is typically a state estimation problem. And once we have or we know the state of the world, or we have a probability distribution describing us how that state is probably looking like, then we can decide what to do in order to bring the world into a different state. Bringing the world into a different state could mean that the system executes a navigation command to move itself to a different place, but this could also mean that we're changing things in the environment, that we are moving objects around. So which action to execute in order to become closer to a desired state. And these are two common problems. This is a state estimation problem, and this is an action selection problem. And the state estimation is something that most of you have seen already in their past. Least squares problems, in order to generate a fit between what you're actually observing and what you're expected to observe, given your state configuration, is a form of state estimation. That's an offline state estimation problem. In this course here, we look a little bit more into online state estimation problems, typically filtering techniques, such as the Kalman filter or the particle filter, where we want to look into a way for doing this state estimation in a recursive fashion. And given we have a belief about the state of the world, then we can decide what should we do in order to bring the current state closer to a desired state. And this is an action selection problem. We can use planning techniques in here. Markov decision processes, for example, are a different way for especially dealing with uncertainties in the action execution. And these are techniques that we will investigate in this course, study in this course, in order to get a deeper understanding how those mobile systems can actually work. So in terms of perception, that's what we are going to start with. There are two kind of key perception problems. The first one is related to estimating semantic information or assessing semantic information, and the second one is related to estimating geometric information. So semantic information means, for example, we take that image and want to interpret which part of the image belongs to a certain semantic class. So like being a crop or a wheat plant in this example. And this is something that we are not really covering in this course this time. This is something that we will investigate more in the upcoming terms and when we look into learning problems. Because this typically involves machine learning techniques, which is not the main focus of this course here today. We are looking more into estimating geometry, so trying to estimate where are 3D points in the environment, where is an object in that world. That's what we're going to start with. Okay, let's dive a little bit deeper and look into the individual problem that we're looking into. So first of all, in this course, there's a short kind of primer on Python, because Python is a programming language that we will use in this course. So we kind of partially excluded it from this course in the sense that it doesn't show up here on the lecture slides, but there is a short collection of videos giving you introduction into Python in case this hasn't happened yet. And this is the basic for the homework assignments, for example. In the lectures itself, Python will not play a large role, so we're not looking into code itself here in the lecture, but it's a key and essential part for the homework assignments. We will start here with, again, a short repetition of a probability primer, basic concepts of probability theory, which will then allow us to derive the base filter, which is a general framework for recursive state estimation. We are then looking into occupancy grid maps. This is the question, is a part of the environment occupied by an obstacle, yes or no? So basically building maps which tell us something about the occupancy of individual parts of the world. And this is a basic representation that is used, for example, for path planning. You can envision them similar to architectural floor plans, for example, where the walls are drawn and certain key structures of the building, and then there's white space, which is basically your free space. And occupancy grid maps are actually very similar to those representations, except that they are built from sensor data and take the current state of the environment into account. Based on those maps, we then can perform localization tasks. Localization can be done with Kalman filters, can be done with particle filters, and that's something that we're going to look into. In order to localize a platform, we first need to understand how they move through the environment. So basic principles of locomotion. So what kind of command do I need to give to a motor in order to make the system move? So motion and motion models, probabilistic motion models will play an important role here, but also the interpretation of the sensor data. What does it mean if I get a sensor measurement? What is the uncertainty associated with this measurement? At least in a very basic form will be investigated, because then that's the basic for actually implementing a base filter, a recursive state estimation technique, because for that we typically need to have models about what is the result of an action and what does an observation mean in there. And again, this will allow us to solve basic state estimation problem. And then in the second part of the course, we are looking into the active parts, looking into robot control. So in this year especially, we extended the control part a little bit with providing a short introduction also into MPC. And then we look into motion planning here, looking into basic planning algorithms such as A*, but also looking into Markov decision processes in order to have an idea on how we can deal at least with basic uncertainties in this process. And so this course gives you an introduction into basic concepts of mobile robots and systems that move through the environment in order to perform state estimation, and will be the basis for most other activities that are happening here in the lab. And if you look into any robotic systems that is out there today, let it be an autonomous car, let it be your vacuum cleaner, they will use elements of what we teach here in this course, how to move through the environment, how to estimate their own state, how to perceive the world. These are aspects that we are going to cover in this course, and the basic principles you find also in much more advanced techniques today or systems today, although their techniques may be more advanced, more adapted to their application. But we are starting here with the basics to give you the foundations to understand what builds on top of this. So my name is Cyrill Stachniss. I'm here responsible for this course and will take care about the majority of the lectures. How you can reach me, either in person, Nussale 15 is where I'm located, where my office is. You can send me an email, which is the easiest way to reach me, or you can call me also on the phone in the office if there is an urgent need to do that. Besides myself, there will be student assistants helping you with your homework assignments, doing the tutorial, hopefully in person this year. If in person doesn't work out, then we have to turn this into Zoom, but this depends on the current situation that we are facing this year. Let's see how that evolves. Before I want to end this introduction, I want to briefly look into some formal aspects that are important for this course. If you enrolled here in this course at Bonn University and are taking it as a student on the internet, so to say. So homework assignments are given out and they come out with a deadline attached to it. And it's important to kind of stick to this deadline. So on eCampus, which is a system which we are using here in Bonn in order to share the homework assignments, and we have to also submit the results of your homework assignments, you will see your homework assignments, and on this homework assignment is a deadline, and please stick to this deadline. So depending on your study program, if you have a larger block module which blocks the whole class, please come to us, talk to us, and we will see if we find an extension for that deadline, but then there's something which holds for the whole course and not just for individual people. We try to make it fair and not punish people who do their job on time. So please stick to this deadline, but if there's a serious reasons why something cannot happen, feel free to talk to us, but please do this early in time, a little bit ahead, not just the day of the deadline, then it's typically too late to change anything. The thing is why homework assignments are important is because first, for your own studying, they kind of deepen your knowledge and make you able to implement the systems on your own, at least in basic concepts. This gives you a deeper understanding what's going on. And also from a formal aspect, we are using these homework assignments as the basic for exam admission. So in order to participate in the exam, you need to earn 50% of the points of those homework assignments. So every homework assignment gives you a certain number of points, and you need to get, on average, 50% of the points averaged over all the homework assignments of this term. That's typically not very hard to achieve, but still requires some work, and if you're below this 50%, you're not admitted to the exam. And in this exam, again, coding is an essential part, so make sure you get used to Python as early as possible. We are using Python since a couple of years, also in the bachelor program here, and most people who applied from externally also have taken some Python classes. For those who haven't done that, we published a playlist with some Python videos which give you a brief introduction so that it should be fine for everyone to use it. It's not very difficult. We are not using very advanced concepts for that, but I recommend you to get used to Python as quickly as possible. You can submit your homework assignments in teams of 2, so not teams of 3, teams of 2 as a maximum. So organize yourself, find a partner among your peers, and then you can submit your homework assignments together as a team of 2. Please don't change the teams on the fly. If there are serious reasons, talk to your tutors and they will find a way to sort that out. But otherwise, you select your partner and then stick with your partner, at least for this course. You have to do your submission via eCampus. That's important. And what is also important, probably the most important information on that slide, is limit the collaboration, what we call among groups. So within your group, within your partner, you collaborate, you do everything together, but not with the outside world. So, of course, you can ask your colleagues if you don't understand a question and you want to discuss something with them. That's totally fine. But stop copying homework assignments or taking code from someone else and integrating it into your homework assignments. So I have a very, very low tolerance with respect to plagiarism. It's actually a 0 tolerance. So if you're cheating with your homework assignments in the sense that you're copying a part of your homework assignment from someone else, you will be expelled from that course. You're not allowed to take the exam. You lose 1 year of your study program. And it also holds for the person from whom you're copying. So I'm fairly strict on this rule because it's totally fine to not do your homework assignments because you don't manage, because you can't do it or you don't have enough time. Talk to us. We'll find a solution. We're trying to support you. But as soon as you're cheating, start cheating, that's something which I seriously dislike, and this will have consequences for you and your study program. So please don't do it. Our life, as well as your life, stays easier if you simply don't submit a homework assignment rather than copying it from someone else. In terms of coding, Again, we are using Python here in this course. Why Python? Why not something else? Why not MATLAB? Python has several advantages, and it became kind of the de facto standard for a lot of scientific programming and prototyping. If you're working more with online control problems, Python may not be your favorite choice, and also for building a large-scale software system, it may not be your favorite choice. You may use something like C++, but it turns out that for prototyping, for the small problems that we're investigating, and especially if speed doesn't play the major role in here, it is simply the easiest way to go to move forward. And so all the homework assignments which involve programming here in this course will be done using Python, and we found it a very, very useful tool. And therefore we're using it in this course, so get used to this. Here's also the URL for a short selection of videos, not recorded by ourselves, but there are very good tutorials out there so that you can start with in case you don't have any Python knowledge yet. Again, this is not needed to understand the videos of the lectures or the lectures themselves, but that's important for doing the homework assignments. With this, I say thank you very much for your attention, and I hope you're going to enjoy that course and learn a lot of aspects of mobile robotics. So thank you very much, and see you soon.